Today in this class we are going to discuss polynomials, and the first topic of our discussion is real polynomial. Real polynomials. This is our first point. Let a0, a1, a2 an be real numbers and x is a real variable. Then f of x is equal to a0 plus a1x plus a2x square plus plus an x to the power n is called real polynomial of variable x. Real polynomial of variable x with real coefficients. These are called coefficients. They are real coefficients. For example, f of x is equal to 2x square plus 3x plus 1, or f of x is equal to x plus 3, or f of x is equal to 5x to the power 4 plus 3x square minus 4x minus 1. These are some examples of polynomials. Now, you should understand and note down one important point, that is how to identify polynomial. Note how to identify a polynomial. Polynomial in x should be expression in terms of variable power x, where every power should be positive integer. Polynomial in x should be an expression in terms of various powers of x, where every power should be a positive integer. For example, f of x is equal to x plus 1 upon x, or you can say f of x is equal to x to the power minus 2 minus x to the power minus 1 plus 1, or you can say f of x is equal to x square plus x to the power 1 upon 2 plus 3. See, it is written that polynomial in x should be an expression in terms of various power of x, where every power should be a positive integer. So when you will have a close loop, this is written x to the power minus 1. So it seems like it is written x to the power 1, but it is not. When you will write like this, because this expression is equivalent to x plus x to the power minus 1, as one term of this expression is having negative power, this cannot be a polynomial. And here the any term, if you find any single term of the given expression having negative power or negative order, it will not be a polynomial. So in this way, it is a positive but not an integer, it is a fraction. So in first case it's look like a positive power, but it is not. This is what the reason it is not a polynomial. In second case, it is clearly written that the power is a negative power, so it is not a polynomial. In case 3, it is written the power is positive but it is a fraction. This is what the reason it is not a polynomial, because to justify the definition of polynomial, the power of a variable must be a positive integer. Now our next topic is degree of a polynomial. Degree of a polynomial. The degree of a real polynomial is the highest power of x in the polynomial. In the polynomial. Degree of a real polynomial. Degree of a real polynomial is the highest power of x in the polynomial, and it can be written as fx is equal to n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 and so on, plus a naught x to the power 0. This is a standard format to write down a polynomial of order n. So this is a polynomial of the degree n. Degree n as highest power of x, and n, where n is a positive integer, and this should be a positive integer. And an should not equal to 0. So these are the conditions you should check and understand the concept while dealing the concept of degree of a polynomial. Now, for example, fx is equal to x to the power 3 minus 2x square plus x minus 1, or you can say f of x is equal to x to the power 5 plus x to the power 2 minus 1. So in case 1, in the first example, the polynomial is having degree 3, and in second case the polynomial is having degree 5. Next concept is linear polynomial. Linear polynomial. So linear polynomial is a polynomial of degree 1, right? For example, f of x is equal to 2x plus 3, or you can say f of x is equal to minus x plus 5. These are the linear polynomial because the order of the polynomial is 1, or the degree of the polynomial is 1. One point you should note that f of x is equal to ax plus b is a standard format to write the linear polynomial, or you can say it is a general degree of polynomial and known as linear polynomial. But the condition is a should not be equal to 0, and this can be the general form to represent a linear polynomial. Next, quadratic polynomials. The polynomial of degree 2 is known as quadratic polynomial. For example, f of x is equal to x square plus x plus 1. You can say f of x is equal to x square or minus x square plus 2x minus 1 are the quadratic polynomial. And the standard format to write this quadratic equation is f of x is equal to ax square plus bx plus c, where a should not equal to 0, and this expression is a general degree of 2 polynomial, general degree 2 polynomial, or you can say this is a standard format of quadratic polynomial. Next concept is polynomial equation. The third concept is polynomial equation. If y is equal to f of x is a real polynomial, okay, real polynomial of degree n, then f of x is equal to 0 is a corresponding real polynomial equation of degree n. You can read this line once again. Polynomial equation if y is equal to f of x is a real polynomial of degree n, then f of x is equal to 0 is the corresponding real polynomial equation of degree n. For example, you can write, for example, f of x is equal to x square minus 2x minus 8 is a quadratic polynomial, then you can write then x square minus 2x minus 8 is equal to 0 is corresponding quadratic equation. Now next concept is, and that is the fourth concept, you can say. Let me check it out how many concepts we have gone through. This is the second concept. Then third concept is polynomial equation. So polynomial equation is the third concept. Now we are talking about the fourth concept, and the fourth concept is roots of an equation. Roots of an equation. These are the short form, or you can say abbreviation, I'm using to write down any word which is there in mathematics. So en to the power n means equation. Okay, so roots of an equation in X are those whose value are those values of X which which satisfy the equation which satisfy the equation. Or if you don't like this definition, I have another definition for you. Or you can say if f of alpha is equal to 0, then x is equal to alpha is the root of equation. The root of equation f of x is equal to 0. For example, let us suppose x is equal to 2, comma x is equal to 3 are roots of x square minus 5x plus 6 is equal to 0. When you will do this by the factorization method, you will get this result. So this kind of problem you have already solved in your early classes in class 9th or 10th. So you are already aware with this kind of problems in quadratic equation. You have solved it by the splitting middle terms. These concepts are not new for you, but because I'm going to deal all the chapters throughout, so I'm giving the basic concepts related to polynomial. So this is one example, because once you are going to replace this x with 2, left hand side and right hand side will be equal. Once you are going to replace this x with 3, so this x is equal to 2 or this x is equal to 3 is going to satisfy the given equation. This is what the reason these x values are the roots of the equation. So these are the topic I wanted to discuss with you. One important point you should keep in your mind, and that is the real roots of an equation f of x is equal to 0 are the x coordinate of the points where graphs or graph of y is equal to f of x intersects x-axis. I'm repeating, the real roots of an equation fx is equal to 0 are the x coordinate of the points where graph y is equal to f of x intersects x-axis. Okay, and the second point is an equation of degree n has n roots. Not necessarily, it is not always necessarily. There may be one root for a quadratic, but equal. Necessarily all real. The roots will be n, right? But all are not real. This is not necessary. So these are the points I wanted to discuss with you. So we'll meet in the next class and discuss the new topic, and the next topic will be quadratic equation and inequalities or inequations. Okay, thank you.